Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Challenging NASA to Prove that Planet X Does Not Exist. Now, an article appeared on the Sun newspaper on November 19, 2017, stating that the NASA astronomer Dr. David Morrison had blasted the Planet X theory. This story followed closely on the heels of another story run by Washington Post on the previous day. So on November 18, 2017, saying basically the same thing. In other words, that there is no threat to Earth. Planet X may be a planet or a dark star in the outer reaches of the solar system, but it will never come close to Earth or threaten Earth in any way. So here we see a photograph of Dr. David Morrison, an astronomer at NASA Ames Research Center, and that he has blasted the Planet X theory, saying basically that there is no such thing and there is no threat to Earth. So basically, what is Planet X and why is there so much controversy about this object? Now, the Planet X story seems to have started in 1983 when it was announced that a dead star that is in the public eye and had been found by IRAS, an infrared telescope in orbit, and that it had been found in the Orion constellation. Then in the early 1990s, Dr. Robert Harrington, whose work, where he had been trying to pinpoint the position of this object, which he called Planet X, and his work was actually published by NASA. And then in the 1990s, he went to New Zealand with his telescope, obviously looking for the object from there. Now, he ended up dying in very suspicious circumstances in New Zealand, which suggests that he did find something and that someone had wanted to keep the story from getting to the public. So if Dr. Harrington's Planet X object was never going to be a threat to Earth, why was he killed? Now, Scott and I have been showing evidence that there are objects in the Sun's corona for many months. Some of these images appear below. So this is an STO composite image from November 15, 2017. As you can see, there is a Planet X object in the Sun's corona. The object seems to be about twice the size of Jupiter, or about the same size as the Sun's core is believed to be. The Sun's core is believed to be 20% of the size of the Sun. Jupiter is 1/10 of the size of the Sun, so the Sun's core would be about twice the size of Jupiter. And this object seems to be about the same size. As you can see, slightly behind the Sun, we can see some corona in front of it. Corona seems to be going out to meet the object. Here we can see it's partially covering the object. Now, in this image, on the left, we have one from September 27th, and this is from October 13th. We obviously can see that we have solid spherical objects in the Sun's corona, and they are making connections with the Sun. We see this root-like connection. These are magnetic connections. I've written about them, and through these they draw plasma from the Sun. And this shows that these objects are in some ways similar to white dwarf stars, have the same capabilities that white dwarf stars have. And it has led me to deduce that these are old stars that have gone through a white dwarf phase. White dwarf stars draw plasma from main sequence stars and make this sort of thin connection. And so these are old stars that have aged, have gone through the red giant, the white dwarf phase, have lost most of their layers of ionizing material. Our Sun is as a main sequence star has a core which is about 20% of its size, or it's believed to be that. And on above that, there are many layers of ionizing material, which it is using to generate energy. It has fusion reactions, I think on the surface, and mainly on the surface, and it generates light. It ionizes these layers of plasma, especially the photosphere, from which it emits most of the visible light. And so these objects are stars. They cannot be planets, because planets would be vaporized in the sun's corona. The sun's corona is at a temperature of 2 million degrees Kelvin. No planet will stay intact in that environment. It would melt and vaporize and become a part of the plasma, and so would be absorbed by the sun. And so these objects come in different sizes, from the same size as the Earth to about the size of the Sun or even larger. And they are solid objects, and we can see them in the corona. And they are, as I said before, similar to, in many ways, to white dwarf stars, except that when they come into the solar system, they do not emit visible light. They mainly emit infrared light, because they have run so low on energy, they're no longer able to sustain nuclear reactions, and they're no longer able to ionize what's left of their ionizing material in order to emit light, visible light. Now, in this image, we see one of these Planet X objects moving away from the sun. And the fact that it's moving away within a CME plasma shows you that the gravitational interaction, it's not what we've been taught it is. If all that was holding objects together in the universe, the gravitational interaction, and if that gravitational interaction was constant, this object would never be able to be seen moving away from the sun at the same speed as coronal plasma. This shows you that the gravitational theory, on which about all explanations regarding what happens in the universe is based upon, is false. The gravitational theory is actually an electrical interaction. I mean, the gravitational force is basically based on an electrical interaction. It's to do with the polarization of atoms within an object, an astronomical object. And it would be the same inside one solar system, because I believe that all material in a planetary system comes from one initial star. If there's more than one star, and most of the star systems in the universe are binary, at least 80% of them, it means that the star that was initially formed fissioned into two stars, and then whatever planets orbit these stars came out as material that was ejected from the stars. So all the material came from the single star that initially formed, and so all this material is connected to the star and is therefore extremely likely to have the same sort of polarizability. And so the gravitational interaction, which is the weak attractive force that comes out of this electrical dipolar interaction due to the polarization of the material, is constant throughout the system, because it all came from one single ball of material, the initial star. But if objects like this Planet X object comes from outside the solar system, then it does not interact in the same way with objects that are in the solar system, because it came from another initial star. So this is obvious when we see what happens here. How can such a massive object, these objects are extremely dense cores of stars, how can they be repulsed by the sun in this way? This tells us that gravity is not anything like we have been taught, or as accepted theory tells us it is. Now, apparently there were some reports in the early 1980s that the object that had been discovered would take 30 years to get here and that we should not worry about it. Well, it seems that after those 30 years have gone by, that the object has come in, and also that it was not alone, because there is evidence of many of these objects being in the sun's corona and in the inner solar system. And these objects are what I call rejuvenating. They're regaining the ability to emit light once again, and some of them are coming close to Earth. And we see here an image from 2001 showing that these objects were here then already. This is from the Yoko satellite, the Japanese satellite from 2001. You see one of these objects eclipsing the sun. And this is not the only object. This is also an X-ray image. No planet, or it couldn't be the moon. The moon doesn't emit X-rays. You can see this object is not black. It's obviously emitting X-rays from most of its surface. And this tells you that this is one of these objects, one of these old stars. And it's not the only one. As you can see, there is a spherical object there, and it's dark. Most of its surface is not emitting as many soft X-rays as you can see the rest of the corona is, but we can see some of the corona draped across the object. This is one of these objects, these old stars, which I have been calling stellar cores, because they are cores of stars, and in most cases this core has been exposed. Now, these objects make magnetic connections with the sun, and the sun has a strong magnetic field. All stars have strong magnetic fields. I believe that it's the star's magnetic field that gathers the material and contracts the material so that it is one spherical object. So it's contained by its magnetic field. But now these objects are stars as well. They also have strong magnetic fields. And when they are within a certain region of space, they could even be in the outer solar system, but they still make a magnetic connection with the sun. When they are very close to the sun, the magnetic connection is so strong that we can actually see the plasma that spirals along these magnetic field lines moving from the sun to the object. But this magnetic connection even occurs when these objects are far from the sun, and in that case what happens is we get a coronal hole. The sun's magnetic field lines open up on the surface, and they become perpendicular to the surface, and so plasma from that region is drawn outward, spiraling along these magnetic field lines, so the density in the corona becomes lower in this region. A coronal hole is formed. But what happens to the magnetic field lines? We know that the magnetic field has to form closed field lines. So the field lines have to close somewhere. They close at the object itself. Then if the Earth is in a position where the stream of fast plasma is flowing from the sun to the object, and if the Earth is inside this connection, then the Earth is impacted by this fast solar wind. So and also these objects, when they are close to the sun and close to regions of high magnetic field, they provoke the sun into having energetic events such as CMEs and solar flares. And therefore, in this way, these objects are able to affect Earth. Fast solar wind ionizes our ionosphere and induces currents inside the Earth, which leads to increased seismic and volcanic activity. And the same way, these CMEs that these objects are provoking the sun into having also will do the same thing. So they will lead to increased seismic and volcanic activity. And we know that a very strong volcanic eruption would be cataclysmic for our planet. So these objects do not even have to come close to our planet. The fact that they are in the sun's corona and affecting the sun is affecting our planet. And therefore they are a threat to our planet. And I think people should know the truth. Now, this is one of the photographs we have of one of these objects. This one was very large. It seemed to be about 1/3 the size of the Sun. So as a main sequence star, it would have been much larger than the Sun. And we can see the plasma connection here it's making from the Sun's corona to it. And we see the ionizing material clinging to the surface of the star. And it seems that these objects, when they arrive in the Sun's corona, they shed this material. The Sun itself has many layers of this material because it's still a main sequence star. But when stars go through the red giant and the white dwarf phase, and they do so because they run low on energy and so start their aging process, they lose most of those layers of ionizing material. And most of those layers that they use to produce light. You can see there's very little left on this object, but it's still boiling off some of it and exchanging it with the Sun, because we see this cloud of plasma which is yellowish here on the side of the object. And we see the plasma that is gaining from the Sun. It's ionizing that gaseous plasma and emitting this magenta colored light through it. And also it seems that these objects start to emit light from the core. And this is a new discovery for me, because I initially thought they were just reflecting light, but it seems now that they are actually emitting light from the core itself, which would suggest that they start or restart fusion reactions from the surface of the core, which leads to light emission. And these fusion reactions are powered by the electric potential energy which these objects are gaining by absorbing energy from the Sun, and which had stopped when the star reached a point in its life when it could no longer sustain these fusion reactions. As we can see, it's very clear in this image of the same object that the light that it's emitting from this region is lighter blue than the blue that it's emitting from the surrounding region. So obviously it's having a stronger ability to emit light or have these fusion reactions that may lead to this sort of light emission from this region. And it is surrounded by the Sun's corona. You can see the Sun's corona is becoming magenta colored as well. This is I think due to some of the ionizing material that some of these stellar cores have brought to the Sun. I believe it may be argon, because argon, when ionized, within an ionizing chamber, it will emit this magenta or pink light. Now, this is one of the objects that was recently photographed from the Earth's surface, and you can see the same sort of thing. It's emitting dark blue light from this region, lighter blue from this region, almost cyan from this region, and white from this region. So this is, I believe, a rejuvenating stellar core. An old star that has come to the Sun's corona is rejuvenating. It's regaining its ability to emit light. It does have this pinkish haze around it. That pinkish haze, it's its outer atmosphere. It's basically its corona. The Sun itself does the same thing. It ionizes material. It boils off some of its material from the photosphere and from the chromosphere, and it produces this outer atmosphere, which we call the corona. So these are definitely stars. They operate in basically the same way as all other stars, except they now have very little ionizing material left on their surface, which they lost in their aging process. Now here we see one of these rejuvenated stellar cores. It actually has boiling hot plasma on its surface. It even seems to be having solar flaring activity, which is indicated here, and much like other stars, except this is a thin layer of material on top of the solid core of the object. And this object is obviously rejuvenated by absorbing energy from the Sun and plasma from the Sun to the point that it's able to actually have a layer of boiling hot plasma. It's able to have solar flares and and therefore CMEs, plasma ejections, as I have been writing that these objects are able, and I have shown them in the stereo images in some previous articles. So NASA, I think if they are serious about proving that Planet X does not exist, then that they should do the following. They should stop using cutoff lines in STO images. They should stop removing data. Now, all the images from November 14th, 2017 were removed from public access websites, and as well as several hours of images after the object shown in Figure 1 appears. And it was just caught, it was probably missed by them. They often go back and remove even that. And they should provide the public with access to their STO live feed in real time. Then, if there is no Planet X, as they say there is, we'll be able to ascertain that fact from data that has not been manipulated. Now, so in addition, I would like to challenge Dr. David Morrison to answer the following question. Why does the sun's corona shrink back as darkness advances across the sun during the so-called STO eclipse season? I tried to discuss this with an astronomer colleague of mine, and he said we can discuss other things except for the sun's corona and what happens to it during the STO eclipse season. He would not have any discussion with me unless I agreed to not even mention that. So what else he told me was that it's fine for us as colleagues to discuss such things as what I was writing, as I am still writing. It's fine to discuss it with colleagues. It's fine as long as we don't tell the public about these things. And it seems, therefore, that it's fine to research and understand what's really going on, and even to discuss it among fellow astronomers and physicists, but it is taboo to take these things to the public. Yet that is exactly what I have endeavored to do, because I believe that every person on this planet has the right to know the truth. And so in conclusion, there is overwhelming evidence that the Planet X object that Dr. Harrington was looking for came in, and that it was not alone. These Planet X objects are here and affecting our sun and our planet. NASA, however, continues to say that such objects do not exist and that there is no threat to Earth. And I think it's time that NASA tells the public the truth rather than continue to hide the truth behind cutoff lines and obviously deleted data. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching. Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Collapsing Ice Shelves in Antarctica and Planet X. Now, on July 12, 2017, a satellite image showed that a piece of the Larsen C ice shelf, and this is the Larsen C ice shelf, all this ice, that this piece of the ice shelf had broken off completely. And since 2010, satellites had been watching the progression of this rift that had developed and was growing. And this is where it was in 2010, and it had grown to there by 2014, and then it accelerated until July 2017. It completely broke off. And so this portion of the ice shelf became a huge iceberg. Now, this had happened before. An iceberg called B-15 had broken off an ice shelf in Antarctica, and this iceberg had was even larger than this Larsen C iceberg. But this happened in March of 2000. So in March it's spring, and it's when Antarctica is warmer, whilst this one has broken up in July, which is the coldest time of the year. And here we see a map of Antarctica. And this is the Antarctica Peninsula. The Larsen C ice shelf is there somewhere. And this is where this recent huge iceberg has broken from the ice shelf. Now here we see the peninsula again, and we see several of these ice shelves that have in recent years been breaking off in this region of Antarctica. And here we see the Ross ice shelf. This is the largest ice shelf in Antarctica. It is the thickest, and I'll show you a photograph of it just now. But this illustrates what an ice shelf is. It's basically a huge slab of ice which is connected to the continental ice sheet, which covers the continent of Antarctica, and it flows out towards the ocean. It juts out over the ocean, and it partially floats over the ocean. And these are actually shallow seas around Antarctica, whilst we see the deeper ocean water here, which is usually warmer than the water in these shallow seas. And these are fed by glaciers, which are like rivers of solid ice, which continuously move downhill and towards the ocean. And this is represented by this ice stream which flows towards the ocean. So glaciers are feeding these ice shelves, and the glaciers form due to an accumulation of snow which exceeds ablation. And ablation is both melting and sublimation. And sublimation is when ice in the solid phase goes directly into the gaseous phase. And here we see the Ross ice shelf, which is the largest in Antarctica. It is 2,450 feet thick in places, and it forms walls of ice which rise up to 50 meters over the ocean surface. But most of the ice shelf will be under the surface of the ocean. Only about 10% would be above the surface. Now, glaciers are slowed in their process towards the ocean by the presence of the ice shelf. So when these ice shelves break up, the glaciers accelerate and they thin and recede and dump more ice into the ocean, which leads to an increased or raised global sea level. So these ice shelves are quite important in that way. Now we can see here a map again of the Antarctica Peninsula, and we see several ice shelves. There's Larsen C, a quite large one, from which the recent iceberg in July of 2017 broke off. But we see there was Larsen A and Larsen B, and these have been breaking up for some years now. And actually the first one to break up was the Prince Gustav, which was right at the tip of the Antarctica Peninsula. And this one completely collapsed by 1995, but for many years, from about the 1950s, it had been thinning and receding. And then next came the Larsen A, which was stable between 1961 and 1980. But through periodic calving, which is the breaking of ice chunks from the edge of the ice shelf, and this led to it receding in steps. And so this is the Larsen A. At one time, the Prince Gustav was connected to Larsen A. So this Prince Gustav was the first one to seems to have broken off. It's now completely gone. Larsen A was the next one, and the next one was Larsen B, which is here. And Larsen B started receding in 1980, and it underwent rapid calving and disintegration to the point that it was almost completely lost in 2002. And then, of course, comes Larsen C, which I've already mentioned, which is starting to break up, as we just had that huge iceberg breaking from it in July of 2017. And here we see a side view of ice shelves and how they are partially floating, and there's ocean water here, and icebergs are break off the edge here, and then they move away from the ice shelf. And then there's what's called the grounding line, and this is where it's a point where the ice shelf rests on the ground, and as they recede, this grounding line will recede as well, and the ocean water will advance towards land. Now, other ice shelves can be seen here that have already undergone, and some are still undergoing this breakup. There's the Worthy, the George VI, and the Wilkins. And these have been breaking up for quite some years. The Worthy ice shelf disintegrated as a result of several calving events during the 1970s and the 1980s, and by 1992 it was not much more than a few disconnected glaciers flowing into the ocean. And then the Wilkins ice shelf, it also underwent rapid shrinkage and breakups in 1998, 2008, and 2009, and it became about 2/3 of its original size. Then the George VI ice shelf, let's look at the map again. There's George VI, is along this channel here. There's the Wilkins. And this one is receding rapidly at the rate of between 1 and 1.1 kilometers per year, and its grounding line is of course also receding. Now, the likely reason for this dramatic breaking up of Antarctica ice shelves is the fact that the ocean around Antarctica has significantly warmed due to the fact that the Earth wobble is increasing. And the sun is not rising in the place it used to, as many people from around the world have reported. And I think some of the first people to report on this were actually the Eskimos in Northern America. Now, when the Earth wobbles in any direction, the North and South Pole regions are no longer at the axis points. So they would, of course, be in any region around where the new axis would be. The new position of the axis would be, and therefore it would be in a region where it will get a lot more sunlight and therefore warm up. Now, in addition, the oceans are warming up from the bottom, and this is due to increased volcanic activity, and also because ocean floors are littered with volcanoes. So when a volcano erupts, it releases hot magma into the ocean, and if it is a volcano on the ocean floor, it releases hot magma into the ocean, which warms up the ocean, and this warmer water, when in contact with ice, will increase the rate at which it is melting. And oceanographic records reveal that dating back to 1960, these are the records dating back, that ocean water around Antarctica has warmed by at least 0.4 degrees C. So from 0.8 degrees C to 1.2 degrees C between the 1970s and 2010s. Now, this does not seem to be a large increase in temperature, but because of the huge amount of ocean water, it means that there is a huge amount of heat available in this ocean to melt large amounts of ice, and this would lead to the ice shelves collapsing, and the shallow seas then will be invaded by this warmer ocean water. So as the ice shelf recedes, this warmer ocean water moves into the shallow seas, and as the ocean water in the shallow seas warms up, more and more of the ice shelf will melt and recede and break up. And so eventually the ice shelf will be gone, and then the water comes in contact with the glaciers that were feeding it. And then these start melting from below, and then they accelerate their movement towards the ocean. And this leads to a cumulative effect of ever increasing amounts of ice melting, and therefore accelerated global sea level rises. Now, why is this happening? Well, I believe it's happening because of the Planet X objects, which are old stars or stellar cores which have invaded the solar system and are affecting our sun, which is in turn having large amounts of coronal holes and other energetic events such as CMEs and solar flares. These are impacting the Earth's magnetosphere, ionizing the ionosphere, and inducing currents in the Earth, which in turn leads to increased seismic and volcanic activity, and through this volcanic activity will lead to warming of the Earth's oceans. Now, in addition, these objects are obtaining energy and plasma from the sun. They are regenerating and approaching the Earth, and this leads to a disruption of the Earth's magnetic field and to the Earth wobbling more and more. And this is because these are stars with very high magnetic fields which impact the Earth's magnetic field and lead to this wobbling as the Earth's magnetic poles shift. So the Earth's poles would then move would be in a region on the planet which, with respect to the sun or the ecliptic, will be receiving much more sunlight. So Antarctica is being heated basically from above and from below. And this is one of the recent photographs where one of these objects was caught. This is an almost completely rejuvenated stellar core. It is now emitting light from the core itself, and this seems to be to the fact that it's gained enough energy from the sun and is now able to restart nuclear reactions from the surface of the core. It does not seem to yet have hot glowing plasma. Some of them I have seen images that lead me to believe that these objects eventually have hot glowing plasma on the surface and can have solar flaring activity and CMEs like normal stars. So, in conclusion, the breaking up of Antarctica ice shelves is an indication of the warming effect that Planet X objects are having on our planet. Both increased volcanic activity and the increasing Earth wobble play a part and give rise to this warming up of oceans around Antarctica, which in turn leads to an acceleration of Antarctica ice melting and the global ocean level rising. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching. Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X researcher and professional physicist, and today I'd like to bring to you another one of my articles. This one is entitled, "A Planet X Object of Unimaginable Size Appears." Now, in November of 2017, a faithful sky watcher from Australia took some amazing photographs of our sun with a camera. And one of these photographs is shown in figure 1 below. There's the photograph. I'm sure you can all see that there seems to be an object close to the sun. Now, so this means that the sun is not alone. It has been invaded by old stars, and I call this system of stars the Planet X system. And that's in honor of people that search for it, like Dr. Harrington. And these objects seem to be attracted to the sun. They drain energy and plasma from it. They mainly emit infrared light when they arrive, so they are dark. We do not see them. But they eventually rejuvenate and are able to emit light once again. Now, the first of these rejuvenated old stars or stellar cores seems to have been observed from just outside Fatima in Portugal on October 13th, 1917, so just over 100 years ago. I have written an article about that. So here is the photograph. As you can see, there is one object that seems to be very close to the sun, and we're going to look at the close-up of that object. As you can see, there are two colors being emitted by this object. It seems to be white on the left-hand side and bluish on the right-hand side. Now this edge, the circular edge on its right-hand side is missing, and this indicates that this object is mainly reflecting light. It's reflecting very bright white light, so this is likely to be light from the sun. The sun is supposed to still be the brightest object in the solar system, and we know that these objects are attracted to the sun, and they go into the sun's corona to absorb energy and plasma and thus rejuvenate. So it's extremely likely that this object is in the sun's corona. It is reflecting light from the sun, this bright white light, and this means that it has to be very close to the sun, and it has to be slightly behind the sun, because if it was in front of the sun, it would look dark. We wouldn't be able to see it, just like during the new moon. If the moon is in front of this is on the same side as the sun, we wouldn't be able to see it. So this object has to be slightly behind the sun, and we know it has to be very close to the sun. So we can do a size comparison, and immediately we can realize that it is about 1/3 of the size of the sun. And 1/3 of the size of the sun is at least 3 times larger than Jupiter. So this is a very large object, and it's very close to the sun. It's in the sun's corona, so it cannot be a planet. A planet would sublimate, would become absorbed as plasma itself in the very hot temperatures that we know that the sun's corona is at, which is at millions of degrees Kelvin. So this cannot be a planet. It has to be a star. It's interesting that it also has this pink magenta haze around it, and I have seen that before, and I've seen that with the blue stellar core. But I forgot to mention something, and that's the blue coloring around this object. This means that this object is also reflecting light from another star, not just the sun, because if there was only the sun in the sky, we should only see the bright white, and we shouldn't see the rest where it looks blue. This seems that the star is reflecting light from another source, more in front of it, but still to the right. I mean, the object is still to the right of it, because this right edge of the object is not visible. So light from this star is not reflecting off this outer edge. So the object has to be to the right of the star. So it also shows that there's more than one light source illuminating this object. One is most likely the sun, the other possibly another one close to the sun. Both would be slightly in front of this object, or this object slightly behind them. And we do know that natural light sources are, of course, stars. Stars emit light in the universe. Planets reflect light. And that's the main division between the astronomical objects in our solar system. Now, the fact that this object is so close to the sun means it's about 1/3 of the size of the sun, but that also means it could be the other object we've seen before, and that was the blue stellar core that was photographed through a small telescope. And these are stars. These are cores of stars. You can see this is the blue stellar core. It was photographed by Scott Sion and another astronomer in Germany, and we see it here, and it tells us what these objects are like. They are clearly solid objects, extremely dense. We know they are solid because there are grooves on the surface, and we can see that they have ionizing envelopes. This one has very little ionizing material, a clinging to its surface. Some of them, when they arrive in the solar system, have very large ionizing envelopes that look like a disc-shaped cloud, and may envelop the object, may be toroidal in shape, some may be nearly spherical in shape, but this envelope is actually left over from the white dwarf phase that these stars go through during the aging process. They first go through the red giant phase. They start releasing the outer layers of ionizing material through the red giant phase, and then the ionizing envelope or the ionizing layer moves downwards towards the core because the star has run low on energy, and eventually it becomes a white dwarf, at which time it stops having, from that point on, it seems to not have enough energy to continue having fusion reactions in the ionizing layer, and it cools down from there. It cools down fast because it's not hot on the inside, just on the outside, and it cools down and eventually is only able to emit infrared radiation, which time I call them brown dwarf stars, stellar core, or simply an old star. And eventually they boil off their ionizing material into gaseous plasma. As you can see, this ionizing material does not even seem to be gas in the gaseous phase. It seems to be solid. And from there I realized that the sun's photosphere is probably a plasma in the solid phase. So if it's a complex plasma, complex plasmas can exist in the solid and liquid phases. So this is possibly what this material is. It's complex plasma. And we can see that these objects make magnetic connections with the sun. There's one of these connections. We can see it there. It draws plasma from the sun, just like white dwarf stars draw plasma from main sequence stars. This is because this object has gone through the white dwarf phase. It still has an extremely high magnetic field, and it connects with the sun through that magnetic field. The gravitational force does not seem to be what we've been taught, and these objects indicate to us that gravity is something quite different. It's actually an electrical electrostatic interaction, and due to polarization of matter that these objects are made of. And we see that there is gaseous plasma gathering under this object. We can also faintly see that the sun's corona goes out to encompass the object. We see yellowish plasma here, pink plasma there. Even the sun seems to have slightly pink or magenta plasma. And this, I believe, is due to some of the stellar cores having brought into the solar system some argon, which when ionized gives off this pink or magenta light. And this object seems to probably have some. The sun seems to have gained some as well. This yellowish material is probably the material that this object is boiling off from what's left attached to its surface of its ionizing material, and it's exchanging it with the sun and possibly other stellar cores that are also in the sun's corona. And we can see that it's gaining this pink emitting gaseous plasma, and we see that this object here also has a pink haze around it and is therefore also producing this gaseous plasma that is giving off this pink light. And a lot of these objects may have developed this ability to emit this pink light from this new ionizing atmosphere that they are gaining through interacting with the sun. And once they are able to give off a lot of magenta light, they would illuminate the Earth's atmosphere. And this may be why we are seeing so many pink and magenta colored sunrises and sunsets and magenta colored clouds. But now let's return to this photograph, because this object is not actually the most surprising object to be seen in this image, because as I mentioned before, the blue stellar core has been photographed before. We know that it is there in the sun's corona. So it may have an orbit that moves it slightly away from the corona and brings it back in, it would still be a close orbit, because these objects are very attracted to the sun and they would not move very far away. Some of them are gathering just outside the outer corona of the sun, which is at about 12 radii from the sun, and they are forming a shell around the sun, which when it's in the right position may give the sun that halo effect, because these are rejuvenated stellar cores that are emitting light. So now the other thing that's visible in this image is the structure here. As you can see, it seems to have concentric rings in it. It seems to be giving off some white light, and but not nearly as bright as either of these objects, this object or that object. So it's possibly a little bit further away from the sun. It has this cloud-like structure. It is behind the clouds here. We do not see the concentric rings coming in front of this cloud, so it seems to be behind the Earth's atmosphere, behind the sun, behind this object. And in that case, whatever object is giving rise to this sort of circular pattern has to be huge, has to be at least 5 times larger, possibly even larger than that, than the sun. But this kind of cloud-like structure I have seen before in some stellar cores, which when they arrive at the sun still have an intact ionizing envelope from the white dwarf phase, except that when they arrive they only emit infrared light because they've cooled down, so they're not visible. But eventually the ionizing envelope becomes visible, because as the star rejuvenates, it starts being able to emit some light from the ionizing envelope, and this is possibly what we see happening here. This is a stellar core, a huge stellar core. At that, it does seem to have an inner circular ring, which is more yellowish in color. You can see the boundary here, and so it shows that there's a huge object behind the sun, and this would have been, this stellar core probably has not been here for very long. They take at least a few months to rejuvenate to the point that they can give off light from the ionizing envelopes. And I have written about these, the ones that I've seen before, usually sometimes Earth-sized, very small. I've never seen one this size. But now, looking at the size of this object, it is of unimaginable size. And given that the cores of main sequence stars are about 20% the size of the star, we know that because the sun's core is about 20% of the size of the sun, and that this star in the main sequence phase would have been at least 25 times the size of the sun. And in terms of mass, it would have been 125 times more massive than the sun. That is according to the accepted theory of star evolution, which is based on gravitational collapse. And if a star this massive existed, according to the accepted theory, it would have turned into a black hole when it started aging. So according to the theory, we shouldn't have this huge object, shouldn't exist at all, it should have turned into a black hole. And this is therefore evidence that the gravitational collapse theory is completely false. Now, this is an illustration of what we seem to have. We have the sun, we have the blue stellar core slightly behind the sun. This is the front view, and we have this huge stellar core where we see the ionizing envelope that is starting to emit light. This is seems to be the inner part where there does seem to be some orangey light being emitted, and this, I think, is the side view. Where the sun is in front, the blue stellar object slightly behind the sun, and then we have this huge stellar core. It may not be as spherical as I've drawn it, it may be more toroidal in shape. but I've just left it like that. A lot of the larger ones that we've seen at the Sun, even though they have ionizing envelopes, they do seem to have them, seem to be spherical in shape, so I've decided to draw it as a sphere. But it may be more like a toroid or a fat disk shaped object. Now, this object must have arrived at the Sun some time ago. It has now rejuvenated enough to the point that it's emitting some light from its ionizing envelope and becoming visible. So the stellar core is, because it's so huge, likely to have a very large weakening effect on the Sun, because they absorb energy from the Sun, and at the same time a very destabilizing effect, because as the Sun weakens, its magnetic field weakens and it finds it more difficult to contain its plasma. That's how stars contain plasma. Contain their plasma is through the magnetic field, which basically compresses the plasma towards the center of the object. Now, the presence of this huge object in the Sun's corona may be the reason why the Sun suddenly started becoming far more active at the beginning of 2017. And it's not so much that it's active, it's actually very weak. We can see it, I've written about that as well, especially from the top of the chromosphere. It's emitting much less light. But the Sun is basically not so much as more active as more unstable. And this means that it's also becoming more dangerous. Now, in conclusion, Planet X system stellar cores started invading the Sun at least a little over 100 years ago. However, a stellar core of unimaginable size has now arrived and seems to have started rejuvenating. The object will weaken the Sun much faster than other smaller stellar cores, and it will therefore have a destabilizing effect, which may lead to more and more severe energetic solar events, such as solar flares and CMEs, and which may be dangerous for our planet. Now, in addition, this object provides additional evidence that the gravitational collapse theory is false and that black holes do not exist. And here are my references. This is the previous work that I have done. Because I cannot just repeat everything for each article, I provide the references. You can go and watch the videos. I've made videos on all of these. And as a final statement, I'd like to say that the Planet X system stellar cores, and especially now this unimaginably huge one, will negatively impact life on Earth. I have also written about this, how it may lead to extreme volcanic eruptions and seismic activity, and I've written a lot about that, and it will be dangerous for our planet, and I think there will be difficult times ahead. I don't think our planet will be completely destroyed, but it will make things very difficult for its inhabitants. So I therefore recommend getting to know our Creator, Jesus, as the only way to find the peace and safety that we all desperately need. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching. Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X research and professional physicist, and today I'd